Team Impact Crew are a team that participated in the 2025 NASA Space Apps Challenge, a global hackathon that brings together diverse teams to tackle real-world problems using NASA's open data alongside space-based data from agencies around the world. Their project, SolMaps Solar Energy Site Optimization using NASA's data, is a platform that identifies optimal solar panel locations worldwide using NASA satellite data to help transform space-based observations into actionable intelligence for governments, utilities, NGOs to make data-driven solar infrastructure decisions. Their project won them the Best Use of Science Reward. Check out their work, links in the description box below.
We are Team Impact Crew. My name is Sushmita. We have Karuna and Ishan. Our fourth team member is busy with his midterms. So we are here to present our project called SolMaps. It's about taking comprehensive data sets from NASA and mapping and optimizing solar energy deployment around the globe.
Hi everyone. So let's see our SolMaps in action. As you can see on the screen, this is a 3D model of our Earth and Ishan is going to make it function. So as you can see, these are the grids, and once you hover over them, you can find the suitability score. So anything above 0.5 or 0.8, it can be a good area. Our project basically talks about how we can synergize and optimize solar energy on Earth. So there are certain areas like Europe and America where solar energy is functional and well built, but we still have areas like Africa and some of the parts of Asia where we still have a lot of untapped potential. That is our main goal, how we can utilize those areas for a better future. If we go through the grid, we have locations in Africa where the suitability score is pretty high. We have South America. This is our top location in Chile, which has a suitability score of 0.95. But our potential sites do not only depend on the amount of sunlight they are getting. We have a lot of other variables. My teammate is going to talk about the data set and the variables, but we have these top 10 high potential sites. Even though Chile has like the suitability score of 95%, but there are other factors involved like infrastructure and cloud visibility. So this is what our data set has found. How we reached to this location, we used NASA data sets and we cleaned it and we extracted the top 8 variables using Python and softwares like SPSS. And we performed statistical analysis, and you can see this is GHI versus suitability score. GHI is basically sunlight per unit area. And as you can see, these green areas are the ones which have very high thresholds. This yellow is mid and red is pretty low on the bar. This is our top site versus the global average. And at the bottom, you can see this is our global suitability distribution. This is the high range. These are the low ranges. Lastly, there's a heat map. There are a lot of, as I talked about, a lot of variables involved. And this is how they correlate with each other. So I'll pass it on to Ishan now.
Hello everyone. For this project we used the CERES EBAF dataset by NASA. So we ended up choosing this dataset because of the variables given and the data given in the dataset. Like it helps calculate the radiation on the surface of Earth, how much heat is hitting our planet and how much of it is getting lost back and how much are we retaining it. So our ultimate goal for this project was to harness the heat that was being trapped inside the planet, basically suggest ideal locations where we can place solar panels to harness the most amount of energy. So based on that, we ended up reaching Chile as the top site, and this was, as my partner mentioned, it involved 8 different variables. Like we calculated temperatures and irradiance on days which were cloudy, which were clear sky, and then we calculated rainy days, and you just calculate all these irradiance on different environments, and then you end up with like these scores which tell you the optimum places where you can put your solar panels to harness the most energy. This is a foundation for companies who want to harness as much energy as possible based on the irradiance.
Have there been any challenges you encountered when creating this project?
The biggest challenge was the data set. So NASA handed us the website and there were numerous data sets out of which like we had to choose the one that was useful to us. Even after we ended up with the CERES EBAF data set, there were like 100 variables inside and we just had to pick like the 8 most suitable ones which were relevant to ours. Otherwise, computationally, it would be too complex. So we just ended up choosing the top. So pruning out the data set and the variables which were useful to our project, that was the biggest hurdle, because the first day of the hackathon, after 2 days, we just spent our entirety of our time on figuring out which would be the useful variables and stuff like that.
Also, I would like to add, so initially we wanted to do it for all sorts of energy, wind energy, thermal energy, but since, hackathon is so very less time and it's very intensive, we could not find the energy to do everything. So right now we have just done for solar energy, but in future we do plan to build it for other sources of energy as well.
What's a way that our viewers can support you in this project?
The entire thing is working on the past data set. So what we can do is make it live, and it's it shows maybe this is too far-fetched, but showing as soon as the radiation hits, and okay, this is the ideal place, or it can even forecast what future 10 years or 15 years in the future, which locations would be the ideals, considering global warming and all those factors. So those are the things that would be helpful. If we add those variables and that kind of data, then we could just put in our model and then make it work. All of our team members have a LinkedIn. Mine is Ishan Wagani. All of us are NYC student in management and analytics course.
You can find a project on GitHub. The whole source code is present there. Also, this app is live on AI Studio, so we can share the links. And yes, you can reach us on LinkedIn.
Sounds
Thank
good.
you so much.